All right, so now we want to find the sum of those two functions. So if we take f and add g, what can we do to simplify that?
No, nothing.
A whole lot of nothing. So that's done. What's its domain?
0 to infinity.
0 to infinity. Hey, done. All right, so then we want their difference. We're looking for f minus g. So we take square root of x and subtract again. Make sure you use some parentheses here. Subtract our whole second function. So we'll get square root of x minus x plus 4. What can we do to simplify that? Nothing. What's the domain?
0 to negative, or 0 to infinity.
Yep, 0 to infinity again. All right, so then we want f times g. So we're going to take our square root of x and multiply it by x minus 4. How can we multiply that?
Change.
Is it squared?
Cancel out.
It doesn't quite cancel. So sometimes I know variables can mess with our heads a little bit. What if this was square root of 3 times 3? What would that be?
3 square root of 3.
It'd be 3 square root of 3.
So x
So,
square root x minus
exactly.
Okay,
It'd be x times the square root of x. For the exact same reason, it would be 3 root 3. All right, and then what if we had square root of 3 times 4? Right, so this would just be minus 4 times square root of x. Can we do anything else with it?
No.
Yeah.
No.
No.
All right, what's our domain?
I don't know.
Same thing.
It's the same thing. Remember, these first 3 always going to be the same.
Forever, always, no matter
Always,
what.
always, always. I don't say that very often. Always.
At least I know I get some answers right. Or I get them all wrong. I really don't.
Well, and that's the hazard. If you get the first one right, you're good. If you mess it up, then you miss them all. All right,
Sucks.
so just be careful. Okay, so then lastly, we want f over g. So we're going to have the square root of x over x minus 4. Can we do anything to simplify that?
Say there's a
Nope.
restriction on 4.
Okay, so what was that?
The domain is 4.
Right, our domain we have to worry about a little bit. So what extra number can't we use now?
4.
4. So if you want to go the interval route, we would say from 0 to 4, but we're going to use parentheses on 4. And then from 4 to infinity.
Who does that in here? Aside from me.
Yep, nobody. I'm okay with it. The other way is right. It's just, this is nice. All right, so then
squigglies look nice.
it can. If you go, well, apparently I just can't read.
Because with squigglies it looks so good.
All right, so if you want to go the set builder route, we could do the set of all x such that x is greater than or equal to 0, x does not equal 4.
Yeah, mine are all like.
It works, it's just not as nice.
I know. I know. Wait a second. I didn't write this. Oh my gosh, I can't make this other squiggly.
All right, so any questions with our second batch here?
See, like this always happens to me. It's just like that
All
one.
right, what are we
goes
thinking
great,
now?
and that
Any
one's just-
ones, twos, threes, fours, fives? All right, we're gonna look at one more set,
Don't make me.
and this is gonna be the one that you're not gonna like because what's everybody's favorite thing to deal with in math?
Nothing.
Fractions.
Oh God.
So don't let the fact that they're fractions throw you off.
Yeah, right.
As soon as you oh, the panic that ensues. We're still doing the same thing. We just have different looking functions. So we've got f of x equals 5x plus 1 over x squared minus 9. G of x equals 4x minus 2 over x squared minus 9.
Can we do a torsion?
What do you say?
Motion.
The legs combined.
Well, that's the whole point. Yeah, we're going to combine.
No, we have to
No,
like
like-
factor out the bottoms first, don't we?
Oh, yeah, because they're the same.
Difference is squares.
Oh, never mind, never mind. I'm just
What are you guys talking about?
Looking for the domain.
Right.
That's
Right.
what
Right.
I'm saying. Looking for the domain.
All right. So
No,
what
no.
value or values is going to mess up f of x?
X.
Yeah, 3. 3 is going to be a problem. If we put in a 3, we would have 9 minus 9, which gives us 0. And -3 is gonna also be a problem. Because yeah, if you did factor that, you get x minus 3 and x plus 3, which would give you those two zeros. Alright, so I'm gonna say from -infinity to -3. From -3 to 3. And from 3 to infinity.
What is it supposed to
Do
be?
you have
Is,
to
Yeah,
write
look
it that way?
or
at
is it,
simmer, you guys freak
No.
out so fast.
No, do you
is
have
it
to
supposed to
write it that way?
be
We'll get there.
parentheses?
What do you mean when you say is it supposed to be in parentheses?
Or is it the 3 supposed to have like, well, never mind. That's an open circle.
I don't know what you're talking
Okay, so then what about 4G? What's its domain?
about. Wait, do we have to write it like that for
It's
this?
the same. Patience, we'll get there in a second.
It's the same.
Simple. Yes, it is exactly the same. So what is their intersection?
Everything.
It's the
Negative
same
infinity
also.
to infinity.
No,
Why?
No, but
Because
you can't use
both of
negative
those
three.
are right.
So we have to write that every time. Okay, you're gonna get to it. I didn't say anything. Talking to
Yeah,
myself.
All right, so this is how I like to see it. What I can deal with.
Okay.
If you put it like that in Set Builder, I'll get over it.
You forgot your other note.
No, I didn't.
No,
Plus or
plus or
minus.
minus.
Oh, I thought you did the equal sign.
That would be special. No, I was going for does not equal plus or minus.
Oh my gosh.
The hazards of the
See,
smart
what
one.
if they
and
have
time.
it again, like one that I would like. Your set builder? Yeah, like I don't. The left one always looks so good, and the
Maybe
right one.
It's easier to
with
write
your
the
left
left one, I think.
Yeah.
But the right one, I have a tendency to want to write it like 3.
Yeah, it's usually.
All right, so now we need to add these two functions together.
No, no.
Yes, we do.
You can just skip that.
All right, so when you're adding two fractions, what do they have to add in order, or excuse me, have to have in order for us to be able to add them? The same denominator. Do these have the same denominator?
Indeed.
Yeah, so put your gripe in. It's no big deal.
Where did they go?
Yeah, until
You
we
have
get to
to
our
get it.
homework and they're not the same.
All right, so now we would take 5x plus 4x and get 9x. 1 plus a -2. Get a -1. Is there anything we can do to simplify that fraction? No. All right, what's its domain? Yeah. What we found from before. So
Oh,
it can't be
Lord.
3 or -3. Okay, so next
Oh,
one,
repeatedly.
we want to subtract. So we're going to take f minus g.
Are we allowed to write? Well, I think so.
And I'm putting that second fraction in parentheses just because it's a good habit to have when you're subtracting. All right, so we need to make sure that we distribute that negative to each part of our second numerator there. So if we take 5x minus 4x, we get x. 1 minus a -2 gives us a +3. Okay, is there anything we can do to simplify that?
If we were to factor it in.
Right, if we were to factor it,
Okay, you can.
it would simplify. How did we say that x squared minus 9 factored?
X plus 3, x minus 3.
Right, because
So
that would be
it's
x
minus
plus 3 times x minus 3. Right, we can cancel out those x plus 3's. Okay, what's our domain?
X cannot equal.
No, same thing as earlier.
Right, even though it looks like -3 is cool here, we still have to eliminate it. Because it would still mess up over here. So if it messes up that beginning part, it's still a problem.
So what's the point of that?
Because it simplified the fraction.
Oh,
So our domain, even though it looks like that -3 is cool, it's still got to be eliminated. All right, so then last thing we need to do, oops, I forgot. I was going to skip my multiplying. So we need to find our product. Okay, so we're gonna multiply these two fractions. What do we need to do? How do we multiply fractions?
Good question.
Well, the second one, Jake has divided.
Right, so hold that thought for a minute. So how do we multiply?
Straight across.
Right, you just multiply straight across. So we're gonna take 5x plus 1 and multiply it by 4x minus 2. What do we have to do? Think I heard it? FOIL, yes. Okay, so we'll get 20x squared minus 10x plus 4x minus 2 all over x to the fourth minus 9x squared minus 9x squared plus 81. We're gonna combine our like terms a little better in a little bit. Alright, so yeah, now if we combine those like terms, let's see, we can take our negative 10x and combine it with 4x. So I have 20x squared minus 6x. And we still got a minus 2 over, and we can combine those x squareds in our denominator. So x to the fourth minus 18x squared plus 81. Alright, can we simplify that at all?
Ooh, now you can do what I said.
I don't know, what did you say? You gotta refresh my memory, so.
A long time ago, and she's like,
Like, the combine them, like, the 20x squared minus.
Not quite, because again, same issue, we've got stuff being added and subtracted. We're only allowed to cancel things when we've got it like being multiplied. Like
When it's
here.
sectioned off.
Right, because these two were sectioned off and we could cancel out a whole section, we were able to do that, but. So can we simplify that fraction at all?
No,
Why not?
because I don't know, understand how you would, so I'm just gonna say no and call it a day.
Alright, so in general, how do we simplify those? We factored in canceled. Would factoring be helpful to us here?
I don't wanna do that. Is
But
that
what
an
would we
option?
get if we did factor it?
You couldn't factor it.
Sure we
Well, you could, but you have to leave the last part out.
Right, we would get two sets, but what would they look like? You guys should all be able to tell me without actually having to do any work.
But you have
what
to
that would
factor
factor
it.
to.
Bottom would be like
Factor it in
X,
the
line
last
six.
part.
I thought you meant awake, I was like.
When the bottom
No,
of
you
the
wouldn't.
next line is like
Barely awake.
Yeah, the bottom would be
Oh wait,
closer. Go back to
never mind, I'm sorry.
X
Hold
squared
on.
minus.
Sarah, what did you say?
It would go back to the same numbers
You
that
tried
we
this.
were before.
Thank you, yes. If we factored it, we'd go right back to the original. Would that be useful to us here? No.
Oh,
Yeah, if we factored it, we would just get what we got before we
So
multiplied
the
that
real
jump together.
question is, do we have to multiply in the first place?
Yes, we did. So the real question is actually, could we have simplified anything here?
No.
No, so can we simplify anything here?
No.
No. Alright,
I don't like
so
my question.
still need our domain. And this is when it's really, really handy that we know how the domain works. Because would we want to have to figure out what makes this denominator 0?
No.
Not so much. Alright. Yes, sir.
now use this one.
Yes, you may. Alright, we've got one more. We need their quotient.
No, we don't.
Yes, we do. This is actually going to be the easiest out of all of them. Scout on. Because again, how do we divide fractions?
You don't.
Plus, wait. You go to the second one.
Right, we're really just going to be multiplying by the reciprocal. So,
You just don't do
we're going to take our first fraction,
Why did we write?
and we're going to multiply it by the reciprocal of the second, because we're trying to divide them.
Oh shoot.
I don't think Jesus used this before, so I don't feel like I need to.
Oh
He
my
also
God.
didn't use like shampoo. That doesn't mean we should be using
It's
it.
fine. It's fine. You're not even supposed to use shampoo anyway. It
Moving
dries your
on.
hair.
Alright, so now, what can we do?
Can we
Nothing.
cross, cancel?
Right, we can cancel stuff because everything's sectioned off and being multiplied. So yeah, we can cancel out the x squared minus 9.
Yes.
So we get 5x plus 1 over 4x minus 2.
I'm just
Can
gonna
we
start.
simplify that anymore?
Alright, where's the hidden trick?
No. Alright, so now it's domain.
It can't be too bad. I lied.
Two times that. Right, if we set this new denominator equal to 0, we're going to have issues at a